So when you come in next period, you'll have an exam. It's going to be paper-based. The first page, guys, the first page is going to be a literal unit circle where you have to fill it in. You're going to have to fill in coordinates, degrees, and radians. That's probably going to take up like 25-30% of the grade. So everyone should at least have a 30 minimum, right? And then I'm going to ask probably a question like one of these here. And then I'm going to ask another, like one of these first four, you'll see one of those. And then I'm probably going to ask another one of these from 5, 6, 7, 8. And then at the moment, I have 4 of these, but I'm thinking about reducing some of them. Because if you can do 2 of them, then there's no reason to ask for 4 of them. So I'm thinking about, at the moment I have 17 questions. And then, of course, there's multiple choice questions. Some of the questions are coming from UH, like verbatim. I'm just taking them out. Some of the questions are, I think I only made up like 3 questions of my own. Know what a coterminal angle is, how to draw reference angles. Pretty much, if you look at your notes and you look at everything we've done, the handouts that I've given you back, and you look at your Delta Math, you have a chance to go look at them, and you have a chance to look at your UH quizzes. If you cover all of that, you should be fine. Think big picture, like what have we been doing? So I am thinking about making it shorter. At the moment, I have 17 questions. I might take out some of these questions because there's no reason to ask 4 of these. If you know how to do 2 of them correct, then you know how to do all of them, right? Because you can easily reference your unit circle that you have on the front page. So I'm gonna do all the odd ones here, guys, just to warm you guys up. I do want this one. I'll probably pick it up on the day of the exam because I want you guys. Don't worry, I see this. I want you guys to have this as a reference. On the exam, I'll be a little more neater. I'll be like cosine of whatever, blah blah blah. Yeah, what's up? Oh no, we don't do the AP curve until once we start doing everything. Once we start, right now we're just focused on this, so there's no curve. It's just whatever it is, and then we might do some corrections, but it won't be like half credit back. It'll be like 25% back or something, But yeah, so don't worry, you'll get an AP curve for the end of the semester exam. When it's the whole content for the fall semester, and then again in the spring semester. Anything that deals with cumulative, you'll get an AP curve. But if it's like specific subtopics, it's just whatever that is. Any other questions, guys? All right, let's see what we got here. It says find the exact values, no decimals, of the 6 trig functions of an angle theta in standard position whose terminal side contains a given point. So 4, -3. What quadrant is that point in? The 4th. So I'm going to exaggerate quadrant 4, and you don't have to be perfect. 4, -3. I'm going to say that's 4, -3 right here. And so what you're going to do, connect it with the origin, like so. Not to scale, it's not perfect. And then draw a reference triangle. The actual angle is this one. That's the actual angle. But you're going to use the reference angle to help you out. You're going to use this guy right here. This is 4. This is -3. So the radius or hypotenuse is 5. If you didn't know that, you could have just done Pythagorean theorem. 4 squared plus -3 squared equals r squared, if you want to call it a radius. 16 plus 9 equals r squared. 25 equals r squared, square root, r equals 5. If you didn't know that it was a 3, 4, 5. And then I guess I'll write SOHCAHTOA here. SOHCAHTOA. And then you're just going to go, let's do the sign first. I'll do it in red. Sine of this angle equals, and then let the reference angle help you out. Opposite over hypotenuse, so -3/5. Cosine of that angle equals adjacent over hypotenuse, 4/5. Tangent of that angle, let the reference angle help you out. -3/4. And then I'm just doing the reciprocal ones. Let's see. Cosecant. Cosecant's the reciprocal of sine. So negative 5 over 3. If you want to put the negative with the 3 or put the negative more in the middle, that's fine. It's not a big deal. Secant is the reciprocal of cosine, 5/4. And then cotangent is the reciprocal of tangent, 4 over negative 3 or negative 4/3, whatever you prefer. Was that straightforward, guys? Nothing crazy? Okay. Number 3, same deal. Negative 5, negative 7. Where are both coordinates negative? Quadrant 1, 2, 3, or 4? 3. Negative 5, negative 7. I'm just going to say that's negative 5, negative 7 here. It doesn't have to be perfect. Connect it with the origin. Draw a reference triangle perpendicular to the x-axis. A line perpendicular to the x-axis is that one right there. So here's negative 5. Here's negative 7. The hypotenuse or the radius, for the moment, later on when we get to polar, it can be negative. But for the moment, your hypotenuse or radius is never negative. For the moment. There will be a time where it is, but we're not even anywhere. We're like 9 weeks away from that. So we're not even going to touch that yet. All right, so I'm going to figure out this hypotenuse here, or that radius. So I'm just going to go negative 5 squared. I guess technically you don't need to put the negative if you don't want to. Negative 7 squared equals r squared. Let's see, that's 25. Negative 7 squared, that's 49. Equals r squared. Let's see, 50 plus 25 is 75, so this must be 74. And then square root, r equals square root of 74. We're okay so far, guys? All right, so SOHCAHTOA, again, same thing. I'm going to write sine, the actual angle. Let me go ahead and write it. This is the actual angle. That's your theta that you're solving for. But I'm going to use the reference to help me out. So I'm going to go theta r. The r inside the theta or the subscript r is reference. All right, sine theta equals opposite over hypotenuse, negative 7 over square root of 74. If you want to put the negative in the front, that's fine. Cosine theta equals adjacent over hypotenuse, negative 5 over square root of 74. Tangent, opposite over adjacent. Negative divided by negative is a, so 7 over 5. If you put negatives, that's fine, but you got to put a negative in the numerator and denominator because they're both, but I prefer 7/5 there, especially if there's no instructions. Just 7/5 is the best answer. Here we go. The reciprocal of sine is cosecant, so cosecant theta, negative square root of 74 over 7. Secant's the reciprocal of cosine, so negative square root of 74 over 5. And cotangent's the reciprocal of tangent, so I'm going to write what? Yeah, 5 over 7. What do you guys think? Not bad, right? I know, it feels like we've been doing this a long time now. So by now we probably got it on lock. Let's see what this says. If angle theta terminates in the given quadrant and has the given function value, find the exact value of the identified trig functions, no decimals. So this is kind of like the same concept. So they're telling you I'm in quadrant 2, and it says sine theta equals 4/5. So I'm going to exaggerate quadrant 2, and I'm going to draw a reference triangle. Here's the actual angle. And here's my reference angle that I'm going to use to help me out. So opposite for hypotenuse, 5. So if I didn't know what x was, we know it's a 3, 4, 5 triangle, so it's negative 3. But if we didn't know it, x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. X squared equals, you subtract 16 from both sides, so 9. X equals square root, plus minus 3. Positive 3 or negative 3? I'm in quadrant 2. The negative. Because you're in quadrant 2. All right, we're ready. SOHCAHTOA. I guess the sign's given. Sine theta equals 4/5. Given. And this thing wobbles too much, this desk here. Cosine theta equals adjacent over hypotenuse, negative 3/5. Cotangent theta equals, I don't usually do tangent first and then cotangent. tangent theta equals opposite over adjacent, so negative 4/3. Okay, here we go. Cosecant theta. Cosecant's reciprocal of sine, so 5/4, kind of given. Secant, SEC, that's a reciprocal of cosine, so negative 5/3. And finally, cotangent is the reciprocal of tangent, so negative 3/4. Sorry, they're all over the place, but here they are. Pretty straightforward, guys. Okay, I wasn't gonna even mention this, but I feel like I should, or else, if I tell you, I don't want to give an answer. What does this mean? Tan theta greater than 0. If I tell you, what quadrant is this true? And I tell you tan theta is greater than 0. What does that mean? That's one of them. There's another one. The third. By the way, I don't know if you guys know. Look, whenever you see tan theta greater than 0, what it really means is, where is tan theta positive? That's what it really means. Where's tan theta positive? What two quadrants is tan theta positive? In quadrant 1 and quadrant 3. Does that make sense? So, by the way, you're the first class that I've given that answer to. The other two classes, I haven't given them to them. But I am recording, so I'm going to tell them to please watch this video because I want to give everyone a fair shot. That question's in there. You know it. We just haven't formally talked about it. But, like, where is sine and cosine positive? Well, in quadrant 1, everything's positive, everything. In quadrant 2, cosine is negative because cosine's x, and sine is positive. So is tan. Tan is also negative, right? In quadrant 3, sine and cosine are negative, but tangent is positive. Do you see what we're talking about? Okay. So just keep a note on that. All right. Question 7. Secant theta equals 4, and I'm in quadrant 4. So if secant theta is 4, that means that cosine of this angle is 1/4. Because secant and cosines are reciprocals of each other. Are we okay with that, guys? All right, I'm in quadrant 4, so I'm going to exaggerate quadrant 4. There's quadrant 4. They don't give me an ordered pair. They just tell me that cosine theta is 1/4. So always do a reference triangle with respect to the origin here, not to scale. Make sure you draw perpendicular to the x-axis, always with the x-axis. Here's the actual angle. It's that angle. We're going to use the reference to help us out. There's my reference. Cosine is 1/4. Remember, the hypotenuse or the radius is never negative. That's 1. That's 4. I put a y right there. So now I'm just going to do Pythagorean theorem. Hey, no, Yanni, that's a demerit. Demerit, Miss Pearsall. I'm kidding. That was a joke. I said demerit for Yanni. Don't yawn. 1 squared. That was a joke, by the way. I know it's not the funniest joke, but 1 squared plus y squared equals 4 squared. And I know some of you probably don't even need to do this. I'm okay with you not doing this because I know some of you can just look at it and be like, child, that's square root of 15. Why are you making me do this? Fine, that's fine. Put square root of 15. Make sure you put negative because I'm in quadrant 4. All right. 1 squared is 1. Y squared equals 16. Subtract 1 from the 16. Y squared equals 15. Square root. Y equals plus minus square root of 15. Which one do I circle? The positive or the negative? The negative. I know some of you can just look at it and just tell me that that's square root of 15. Make sure you put the negative because that's where most of you probably were going to get some wrong there. All right, here we go. Cosine theta equals 1/4. Kind of given. Sine theta, opposite over hypotenuse, negative square root of 15 over 4. Tan theta, tan is opposite over adjacent, so negative square root of 15. Secant theta, 4, that was given. Cosecant theta, CSE, cosecant's the reciprocal of sine. So the reciprocal of sine of, let's see, 4 over square root of 15, negative. And finally, cotangent is x over y, so 1 over negative square root of 15, or the reciprocal of tangent. If they tell you to rationalize it, then you would rationalize the answers. I don't see any errors, but let me know. I make mistakes all the time. Are we okay? Okay. All right. I ask a whole bunch of these. Remember, you have a whole hour. Well, really, you have the whole class. So this is why it's so important to, when you take your UH quizzes, that you do it like, okay, let me go tell you. I think I already told you, but just in case. When I make my exams, I base it off of how fast you guys are as a group. If I see you guys speeding through some of the assignments, like just going so fast, I just assume like, wow, they can do these questions so fast. So I just put what I think is an hour's worth for you. And what happens usually sometimes, especially if you're going real fast, I time my exams for an hour, and then after an hour and a half, you guys are still working. And I'm like, well, how is that possible? They did like all these UH quizzes and Delta Math so fast. So this is why I give you guys a warning. If you're using like AI or some other app to help you with your Delta and your UH, I mean, I guess, you're just cheating yourself. But, when I create my exams, like, I thought you were that fast. Because some of the questions are going to be verbatim. So, you know what I mean? So that's why, every now and then when that situation happens where I write an exam that's an hour and the bell rings and you guys have taken an hour and a half, I'm kind of like, what's going on? Like, I wrote this exam to only take up an hour. Why are you still working on it? So that's when red flags really come up. So try to be honest because, I look at the aggregate data, how we're doing as a class. And based off of that, I try to create an exam that's an hour's worth. So it should take you about an hour. If you finish a little faster, that means you're pretty fast. If you finish a little later, that means, that's fine. You got 30 minutes extra. So does that make sense, guys? Okay. So you can see the logic. I put a lot of thought into what I do and how I do it. I hope I'm sure your teachers are doing the same. Okay, number 9. So it says, find the exact values of the 6 trigonometric functions of a given angle. So I have 60 degrees. So I'm just going to write cosine 60 degrees, sine 60 degrees. Make sure to put a little degree symbol there. Tan 60 degrees. Sorry, my desk is wobbling, guys, so that's making this hard. So my handwriting is even worse than usual. Secant 60 degrees. Cosecant 60 degrees. And cotangent 60 degrees. All right. You'll have your unit circle to reference, assuming that you filled it in correctly, right? Because if you filled it in wrong, it might. I'm sure everyone's going to get it right. We've been doing this since the first day of school. Cosine 60. Oh, man. I kind of wanted someone to tell me. It's a half, right? That's 60 degrees. Okay. Sine 60. Square root of 3 over 2. Perfect. And then tan is y over x. Yes, you can tell me square root of 3 over 2 divided by half, but I would prefer square root of 3. I prefer square root of 3. Secant 60 is the reciprocal of cosine. The reciprocal of half is 2. Cosecant is the reciprocal of sine. That's fine if you tell me 2 over square root of 3. That's fine. 2 square root of 3 over 3 I think is a little better, but that's fine. And then cotangent is the reciprocal of tangent. So 1 over square root of 3. That's a perfectly acceptable answer. Or square root of 3 over 3. Cool or not cool? Cool. 315 degrees. Some of you are messing up with the negative angle, so let me give you a visual of where that one's at. So here's my unit circle. Negative 315 degrees, if I go clockwise, is right here. It's a terminal angle to 45 degrees. Excuse me. See? 45 degrees and negative 315 degrees share that same segment. Does that make sense? And then that coordinate is square root of 2 over 2, comma, square root of 2 over 2. So maybe this is the easiest one for everyone because you don't have to really think. Cosine and sine are the same. Cosine of negative 315 degrees, square root of 2 over 2. Sine of negative 315 degrees, square root of 2 over 2. Yeah, tell me, guys, tell me. I make mistakes all the time. Yeah.
I think I'm doing it wrong because when it says negative, I just go like on the
No, this is why we told you. And this is why I mentioned it. Good thing I brought it up, Miss Henderson. When it's negative, you measure the rotation. Okay, let me go around here. Okay, I'm going to unplug this. Will it mess up my video recording if I unplug it? Maybe, right? Because it might not have enough power. Okay, look, I got a laser. I had to pay extra for this. You have to have a subscription. Look at my laser. Okay, when I go clockwise, see, so if I go counterclockwise, so counterclockwise 315 would have been right here. That measurement, right? But if you go negative 315, you do the same rotation, but clockwise. So you don't reflect. See, this is, that's negative 315 like that. See? So that's a good thing I did this to get you. And it's the same reference angle as 45 degrees. Did you guys like that laser? I never got a chance to use it until now. Isn't that cool? Yeah, I had to upgrade to Pro Plus. In case you're wondering what software I'm using, it's called Dropboard PDF. It's really cool, as you can see. Anyways, if you say that you're a student, I think you get a discount. I think it's really cool. I think it's worth it because you get to use it. So like, it has pressure sensitivity. Okay, I'm not trying to sell the app, so let me. All right, here we go. Tan of negative 315 degrees, 1. Y divided by x. It's the same magnitude. Do you guys see that? Okay. Secant of negative 315 degrees. Secant's the reciprocal of cosine, but not that it matters. Cosine and sine are the same. So 2 over square root of 2. You can also just say square root of 2, right? Times square root of 2 times square root of 2 will be 2 square root of 2 over 2. The 2's cancel out. You guys know what I'm saying? Okay. Cosecant of negative 315 degrees. Same thing. 2 over square root of 2. And let's see, which one am I missing? Cotangent. Cotangent of negative 315 degrees. Make sure to put a degree symbol. 1. The reciprocal of 1 is 1. Or you can think of it as x over y. You're going to get 1 again as well. Does that make sense? Okay. I said I was going to do all the odd ones, so I guess I'll do 13. What's up? Yeah, if you're rationalizing, you're going to multiply it. Oh, you know what? You brought up a good point. Some of you on the unit circle quiz are just telling me this, and which is, I guess, I mean, I know what you're doing, and then you just go right into this. Guys, it doesn't work that way. You got to multiply it by 1. And I know you're just saying, like, chop, I'm multiplying the numerator and denominator by square root of 2. But you got to write square root of 2 over square root of 2. Because that way you're showing the grader or whoever's reading it that you're multiplying it by 1. And when you multiply it by 1, it doesn't change. And I know you're saying, like, chop, I'm multiplying the numerator and denominator. That's just for me. But guys, when you start doing your thesis and your work for your doctorate and all that, like, you got to be super detailed. Do you guys know what I'm talking about? Like, when you become a doctor, a medical doctor, like, even though you know the terminology, you got to be super detailed because there's pharmacists, there's psychologists, and all these other people that are reading your notes. And if you're not super detailed, like, yeah, if you're talking to another colleague that's another doctor, of course you can use your banter for your terminology and your shortcuts. But as soon as a pharmacist comes in, like, he doesn't know your banter. Like, do you guys know what I'm talking about? So you got to be very specific, and so it starts now. So square root of 2 over square root of 2, that's just 1. And yeah, you get, I guess at first, 2 square root of 2 over 2. And then look, these 2's cancel out. It's just square root of 2. That's rationalizing. Did I answer your question on this? Okay. All right, here we go. 180 degrees. I'm just going to go right into it. Cosine 180 degrees. Sine 180 degrees. Tan 180 degrees. Let's see. Secant 180 degrees, cosecant 180 degrees, and cotangent 180 degrees. Okay, cosine of 180, what is that? Negative 1. Sine of 180. Tan of 180. It's y divided by x, so 0 divided by negative 1 is the same thing as 0. Secant of 180. Secant's a reciprocal of cosine. The reciprocal of negative 1 is negative 1. It's a special number, the number 1. Cosecant of 180. Well, 0 doesn't have a reciprocal, so you say undefined. Cotangent of 180. Again, tangent was 0. Does 0 have a reciprocal? No. You can also think about it as x divided by y. 1 divided by 0 is undefined. How do we feel? Okay. There will be a no calculator section and a calculator section. Relax. You've never used a calculator for the unit circle. So you're good. Like I want to make sure that you know this here. Where are you going to be able to use your calculator? There's a 30, 60, 90 triangle in there. There's a 45, 45, 90 triangle in there. Which I guess I wanted to ask actually those questions first because from there that's where we derive the coordinates for the unit circle. But when I was looking at the questions, like maybe you'll need a calculator, maybe. If you're strong with arithmetic, you won't need it. But if you're not strong with arithmetic, you can use your calculator. Any questions, guys?